Welcome to the lecture series on object-oriented analysis and design. The case study of vending machine is useful to illustrate that the more we focus on the action to be performed by the user who does not really bother about so much of technology, so much of software, the faster the user would begin to take to this automated way of working, and the more he or she wants, the business grows. While saying so, it is not true that object oriented analysis and design is the only way of managing all these simple case studies that I have been talking about. There are many other paradigms. Object oriented analysis and design is promising because it is allowing us to understand that the user starts with some simple ideas, puts those simple ideas together. What was the simple idea first? I want to buy a snack. Then gradually he builds forward, he or she will build forward, saying that what are the snacks available. Where is the focus? The focus is on that simple idea called buying a snack. It is true that we need to do all the things that we have been doing with other ways of programming, but then this way of looking at it makes us become user centric at the earliest, and the user thinks that this machine is simply an extension of what he or she has been thinking and wanting to do. It is almost commonsensical that the machine will talk in a manner where the user simply thinks that he or she is interacting with an agent which is acting as per their thinking and as per their wants. That is the best that we can think of. There are a good number of applications which have been built using object oriented analysis and design with a degree of success that underscores the fact that we need to encourage that bottom up approach to building things. While arriving at that bottom up approach involves some kind of analysis from the top, what are the functionalities, but the way we are looking at it is so different that even the fellow who is developing will very quickly come to the understanding that this is how we will start, saying that how can a snack be purchased by a user, and then build the things that are necessary to make it happen. It is an outlook which we have to understand. Otherwise, we have not shaken the traditional mold of saying that we need a well defined input to have a function written on the well defined input to make it a well defined output. It is just that we are looking at the well defined input alongside the function, and the way in which the well defined output is happening is also alongside the function. It is not that the data, that is the input and output, is completely separated from the function. We define the functions along with the data. So, how will the vending machine as a representation in the machine happen? Because the user wants to buy a snack from a vending machine. Now, all this simply means that we expect the specification to be written in such a manner that it becomes very obvious in one reading that this is the action to be performed. This is the task to be performed. Now, how is it written like that? To make sure that all these words written in blue are certain things which are more from the machine, the objects, the classes. All those that are written in the red are how these objects are connected. Say for example, as I kept on saying, that there are a few things on my table here. What is the problem that I am solving? I am simply trying to solve using the things that I need to lecture. What is my task? The lecture. There are 50 things in this room, but they are not related to this task. It does not mean that outside of the 3 or 4 things others are not necessary. They are also necessary. So, imagine a situation where as I am tasking myself to do this lecture, a few things, 4 or 5 things are coming together to make me complete this lecture. I am happy. It is true that the other things are also there, and I know the value of this place where the other things are necessary, but it is not immediately coming into the focus on the task at hand. This is something which is very special about the bottom up approach. You do not have to know the truckload of things. Walking into the room, please make note of everything that is there in the room, make sure everything is like that. It's a nice model to understand that we will get a big picture. We do not have to limit ourselves to a narrow idea about so many things that are happening in the room, but then we are very efficient in doing exactly what I want to do. If time permits, if necessary, we will build on every other thing. So, we are not disputing the fact that there is a need for top down approach, there is a need for bottom up approach. This debate has been going on for several decades. Should a typical unit developer know the entire story about what is the project that is happening, the big picture? We have seen projects that have been talking about a huge wall that is representing all the things that are happening in the project, and one small point is being developed by an individual. That is a developer centric view. The user centric view is, I want to do only this, if it has permitted me to do this in reasonable time, efficiency, and I am satisfied with the way it is performing, everything is done for me. There are so many other things associated with the vending machine, but please remember, this is all is a specification that is necessary to first get started. It is a very complex exercise. The vending machine has to be located in a place. We should find a power supply for that. So many times it happens that they will have to make a very special socket to get the vending machine operational. So many times because the block is not designed for it. There was no scope for thinking of an automatic coffee vendor when the block was designed. Now there is an automatic coffee vendor possible. They want to plug it in and make sure that it works. For those people who are looking at it, can just go pick up a coffee and then go on working. Things have changed, the work styles have changed, people have been working in different time zones, different time slots, coming from wherever. So, we are not really talking about the full experience of only work at home, but a mixed experience where we have been moving, we have been finding that we have to wake up at odd times, we have to take calls at odd times, we have to be at odd places. So, the point is, we need to understand that we have gotten used to this hybrid mode of working to a point where even the classroom lectures will now start permitting, saying that let them get a mug of coffee and then still attend the lecture, because that fellow was traveling somewhere, he just reached. Now, all these things are possible at a slightly different culture, which we need to understand and appreciate, but in all these cases what is imperative is we cannot generalize, it is tasked. For this purpose, for this lecture, this particular fellow walked in with a mug of coffee and went. It is a specific case. He is happy, I am happy, because he is not making anything generic. So, that kind of a localization, that kind of a clarity is possible in bottom up approach. It is very, very clear. It is limited to only that class, that student, between the teacher and the student. It should have been like that most of the times, but then with all the kind of surveillance and the social connectivity, it has become a bit of a complex exercise. One fellow comes and we keep on telling that the golden law in administration is one is too many in administration. We can't help it, it means so many things. So, it is not that administration will wait for a sample, only 50 fellows have done, I will take note of it, one is too many in administration. That is how we keep talking about it. So, as we go to the rock bottom and start moving up, it becomes a big difficult exercise. So, we said we will have bottom up, the task is clear, the functions are clear, the things necessary are clear, let them do this task, finish it off and go. 20 people will do 20 tasks, that is a software, but that is exactly what it is made for. Some things are related, some resources are shared, all these things we will talk about one by one. Now, nothing is there in this specification. We are not going to have a specification that drags us further and further and further into all these details. The devil is in the details, and at no point in time we can confidently tell that we have documented the entire set of requirements. Hardly 30% of requirements tend to be stable. 70% of them change as we progress in the field of software. The very nature of software engineering is like that, is not to compare with other engineering disciplines, it is like this. If the software works, it works. So, we started off well with the project mode, then we started calling everything as a product. In a product mode, this is even more essential to understand that it is the bottom up. It is expected to do this, it has done this. If you are happy with it, please go ahead, use it, get better version, next model, otherwise you have to just throw it away. So, what we have done is very simple. We started looking at a reasonably well written explanation, Word document, expression, set of expressions on what that vending machine is for us as software developers. This is what is a vending machine. We do not see any prototype, we do not see very many things. So, what we have done is we said that let there be nouns which are marked in blue, they are objects. The verbs or actions that are marked in red are the way in which those objects interact. Problem domain object, let us separate object class into presentation specific and problem specific. So, these are certain things which are problem specific: vending machine, snack item, price, calories, selection and user, of which the top 5 are different functionalities. In the earlier way of working, the structured programming, we started expanding on all these. Vending machine, let us have a team that defines vending machine for me, whereas here I will say that right now I am not in need of the entire vending machine. What I am need of is first things first, display screen, selection buttons, item dispenser, money receptacle. If I know this much, I know everything about the vending machine for the purpose. Snack item will have a team that is talking about snack items, prices, calories, selection. All this is functionality, and by the time we wriggle out of all this functionality, the user is completely forgotten. Projects get delayed on time, they become prohibitively expensive, our estimates have gone woefully wrong, and at the same time we are not telling that it is just a prototype. Prototypes had their way for some time. Rapid prototyping was a good idea, but prototype does not do anything. It simply tells that a toy model, you are making an aeroplane and out of which you created one toy model. Between this toy model and aeroplane, the ocean of a difference. This is how it looks, you can keep it on the desktop. This is the sleek model of an aeroplane. When will the aeroplane happen? These are all difficult questions, whereas here in the field of computing, we can always tell that we will first give user the top rung. He looks at the display screen, he or she, selection buttons, item dispenser, money receptacle, and from this we want to make sure that all this functionality happens. We are not away from this functionality, but the start is not from here to take us here, the start is from here to take us there. So, we talked about not only the user interface, not only the usability, but a completely different way of writing up the program itself. The programming paradigm is object oriented programming paradigm. What is the data? Operations. Now, if you tell that the data is for us is something related to the display screen, the operations are all together. The object called display screen is available to you in its entirety. Otherwise, what is happening? Let us say the display screen is here, but then if I have to do anything with what I am trying to say locate snack, I will have to select 3-4 menus and then go and find out where my snack is. Imagine that they are all segregated as something like Kellogg's snacks, something like Parle snacks, something like Haldiram snacks, and in one of those snacks I will find my snack. That is going to be difficult because what I want to see is what is available right away. You are not going to ask me to remember the brand of the snack I am buying, Lay's snack, Haldiram snack. We are not so specific. We are not at all so specific. We want to buy a snack. What is the condition? This is the calorific value. Anything that is fitting the calorific value is okay for me. So, if that is all is the constraint, this is the vending machine that I wish to see. In my mind at the earliest, what should come? What should come is this picture. that is what we have been talking about, namely the vending machine which we have seen. This is the picture that you should create in the display, not asking me to select one more. Oh, you want to purchase a snack? Please, you are welcome, most welcome. Now you select which brand of the snack are you going to purchase. There are so many brands, you give 20 brands. Now within the brand, what are the snacks that are available? Within the snack, what is the kind of a calorie? It's 3 menus down and we would have lost it. The other day in the earlier lecture, I was talking about Amazon. They had the same concern of having the books on display, one-click technology. Whatever you want to do is just one click. Very efficient way of building the technology. What is it that we want? We want to reflect the mind of the user as much as possible, rather than the mind of the programmer, who is always wanting to have the set of instructions run on the machine, not on the user, but sells the instructions to the user saying that switch on the machine, follow the 10 instructions, you will get whatever you want to do. Not the intention, not the intention at all, but the entire programming paradigm had to change to understand that we need to be completely different, and that is exactly a paradigm shift that we have created. And what we have done is from problem specific to presentation specific. It is not algorithmic specific, it is not instruction specific, it is presentation specific. What is that presentation? Not merely a user interface, another windows, another icons, menus, pointers, but the way the user gets into acting, gets into tasking himself, gets into making the task done as though he is doing, without he getting bogged down with any set of instructions. So the entire way the paradigm has changed. Object oriented analysis is a very promising paradigm. It didn't happen overnight. 4 decades it was lying in the cold storage. We did have this concern when we started talking about programming, program engineering. We ran into a black decade. 71 started with the roaring success of Unix, a mammoth software piece by any yardstick, which was developed in a manner where most of the university students were participating very actively. It was a roaring success in 1971. There are 3 people, that is Brian Kernighan, Dennis Ritchie and Ken Thompson. All 3 made it happen, but then that entire decade there was no matching success. The decade ran through and people were still talking very highly about the success which Unix has shown all along. What happened? What's the reason? So addressing that as a black decade, a solution happened saying that the secret is the programming language, the language in which you are expressing the solution. Nicholas Wirth came up with Pascal, and immediately we started talking about the way in which it has disciplined the way we are expressing the solution, where we are not bogged down by the instructions, but we are bogged down, if at all, by the structure of the program, which tells that this is how the functionality is, this is how each function is related to the other function. Please see the left side of my left side of the screen, structural or procedural program. Then what is the problem with that? The problem with that is that we are not able to scale. Suddenly you want to include one more function. You have to understand where that function fits, right from the top down, from the specification, or to delink another function. That has become extremely important, because 70% of the specifications are changing. If you have to put in one more function, you simply cannot add that function. You will have to understand where it should fit, how it should fit. Even to take it off, you should understand. We tried to have a very good design principle to tell that this is how a function is defined, but we didn't have very many design principles. We had good concepts, we had so many other nice things happening by 85, from 1969 to 1985. Very good progress has happened in an area where it was completely abstract. People were not too sure whether what they are doing is anything outside of black magic, if they are not doing only puzzle solving. If it works, we don't know how to explain why it is working also. Then we moved over in 85 to face another stiff challenge, saying that no, we are not able to scale. We want more, there is a hunger for more and more and more, but then we are simply not able to have a design method. We need to turn practitioners. The practitioners approach happened in the process. we found that we are not able to justify that discipline called software engineering in the way we have taken to developing in the original model of structural program. Therefore, the object oriented program, a language C++. So, the constructs that I am using are primarily to talk about what is the equation with C++ as a language. It is not the only language that fits the bill. There are so many languages. As a matter of fact, the very first language design that was completely built on the foundations of object oriented analysis and design is Smalltalk. Please do read, there is plenty of literature available on the design of Smalltalk, and when you are looking at this Smalltalk, the design of Smalltalk, you would understand that the nuances of the language that fit the bill for this programming paradigm are completely different. We need a new way of understanding that language. Class, as we keep quipping, C++ is not C++ something. We need to understand that there are three major ideas that go behind classes. One is of course class, object oriented, data encapsulation, data hiding, inheritance and polymorphism. Data encapsulation is something that tells me that as long as the vending machine is there in its entirety, please do not bother about the nitty-gritty of that. Even if you want to find out, we will have a simple board saying that if at all it works, you are happy, if it does not work, sorry. That is all we can tell. You do not have to shake the vending machine to make it work. You know, the common instinct in all computing platforms is that if something is not working, reboot, Control Alt Del, a very common way of resolving the problem. It cannot happen with a vending machine. If it is working, it is working, otherwise we regret the inconvenience caused. All that you are worried is when it is working, is it working correctly. So, it is tasked. As far as the user is concerned, he need not know the nitty gritty of the vending machine, who owns the machine. It is there, it is working, these snacks are available, and in a quick time they will figure it out. Users are very smart, we cannot underestimate their capability. They have to be simply pointed at, these are the things that are available, they will automatically figure it out. We do not need a PhD to figure out how to operate a machine. Most of the times we are successful, most of the times. Where is that skill shown? We talk about the toddlers again. Put apples and oranges together, the toddler makes the classification perfect and quick. Apples are out, oranges are out. Give a toy, they will fiddle around with that, in quick time they start operating. So, there is something that we need to understand, that the way we are working with object oriented is more like classification of things. To solve this problem, what are the things that are necessary? How did I find out that I need exactly 5 things, I mean in the middle of 50 things in this room to complete the task? That's the skill, that's the classification. I know there are 50 things, but then I know that only 5 things are necessary for me to do this task. If I have a better task, if I have more things to do, I will talk about other things. But for this task, I am quite confident that only 5 things in this entire room are necessary. Even if I want to know what are the other things doing, a very legitimate reply will be, no, you need not know. Please concentrate on the lecture. There are so many things. So, for doing this, you need this many things. You found out this many things, that is good. You need to know this is the menu, this is the button, this is what I have to select. We will learn it in a quick time. We are all good in moving into different contexts and making them happen. Even if I want to know, there is no need to know. That is what is encapsulation. Data hiding is, nobody else is telling me what the other things are here for, neither am I interested in. They are there, 50 things are there, only 5 things are illuminated, 45 things are not illuminated. And if I want to find out, the system can legitimately say that, sorry, you need not know about it. There is no need to know this. Inheritance, the whole idea is snacks. Snacks is the class, the biggest class. in this snacks we said that there are several other things which the system will take care, but one thing that is common is calorie value should come, price should come for any snack that is taken. If there is another object snack, if it is Haldiram's, maybe that object will put this is Haldiram snack, this is Parle snack, this is somebody else's snack. Tomorrow we want to have another functionality, cool drink. The existing machine is not serving cool drinks. You can put one more functionality for cool drinks. It is like that. Well, if you want to, you can tell that how does it matter. We'll remove one of the snacks and put cool drink. You can, but then the tray, the other related things, it is not the same way of pushing it across. So what we have done is we couched all this in a language which is necessary. That abstraction is necessary because unless we talk in this language of programming language, the solution is not appealing to the developers, and we really do not know how the compilers will make it happen on the architecture. So we started creating this language, C++. Otherwise, as you rightly observe, we are only talking about things which have nothing really to do with software engineering or programming. We are talking about other things. So what we have done is very simple: classes and objects. This is how it is. There is a syntax, there is semantics. There is no reason to believe there is only C++ that is fitting the bill. There are so many other languages. So if you want to really look at the language design, there are 3 language designs which each one of us should study. The first one is PL1, which is a very nice language. It didn't take off. Not many people were successful using PL1. Next language is Smalltalk. It was again very good idea. It tells precisely, as you work out these things, it will show on the screen on the panel that this object, when it is put with this object, can do this much. This thing, when it is related to the other thing, can do this much. It becomes very obvious. The idea was good, Smalltalk was good. A third language is Ada. If we understand the language design, then we will see the need for an abstraction at the level of expressing the solution. We cannot hope to talk only that language which we have been talking to illustrate how these things can happen, because today it is vending machine, tomorrow it is an elevator, day after tomorrow it is purchasing the tickets of the metro, another time we talk about Amazon, another time we talk about a theater purchasing the tickets, another time we can talk about something else, simply going and doing something online. So the application domains will vary, but then the principles are the same. This is how we should address all the applications. Can be many, but the core designs, the way we talk about, the way we approach, that is a paradigm, object oriented analysis and design, which gives me a way of expressing in a manner where it is in the domain of the developers and ready to go on to the machine without sacrificing the original start of a bottom up and user view first. So we defined the class, we defined a class called rectangle. All these things are constructs that are picked very deliberately from C++. We talked about data members, the common attributes of a group of entities, their values determine the state of an object. So the object is something which is arriving as an instance of a class. The class is what we define. It's a class of snacks, out of which this particular snack is only an object. Can be of any type, built-in or user defined, non-static data members, each class object has its own copy. Now you see, all these abstractions are necessary because our goal is to come up with a generic solution. We cannot hope to spend all these ideas, all these efforts, all these monies, all these energies solving exactly one problem. The strength of software still remains as the abstraction, and the generosity with which we can develop it cannot be initialized explicitly in the class body, static data. There are some rules, like every language, it has its own features. So now you see the class rectangle has given 3 rectangles, objects R1, R2, R3. R1 has a separate width, R3 has a separate width, R2 has a separate width, there is 3 rectangles are there, we created 3 rectangles as a count. Now, what is the point? Even though there are 3 objects, to understand what to do with a rectangle, I do not need to lose myself in that many objects. I need to understand this. Class rectangle does only this much. It finds out an area, int area, area is a function. Whatever be the rectangle that you are creating out of this class, all that I am going to find out is the area of a rectangle, and this is how it manifests. Rectangle 1, rectangle 2, static int count, it tells how many rectangles you are going to create. Static is a data type, it is just there in the memory and you do not lose it. So, that is how it is. Memory allocation, how is the memory allocated? As and when you want, it is dynamic allocation. So, three objects are created. In the last class also we have seen this. I would move over to a different presentation from the next lecture, but then what is necessary to understand is that it is enough if I can find out what is the class. It has every class has 2 generic functions, and every object created will have 2 variables. All objects will have only 2 generic functions, which I know when I have created the class. Memory created when functions are defined, otherwise we do not create. Memory created when objects are defined. You see, an aeroplane which has just taken off is really talking about 500 gigabytes of data along with it. An aeroplane that is in the hangar waiting to take off, waiting to come to the tarmac, coming out of the hangar, is still taking 5 gigabytes minimum data. I am being very modest, but then these days plenty of data about aircraft is always there, but then they do not occupy dynamic space, they are just there. Only when the flight is going operational, all that data will be packed, otherwise it is still there. Memory created only when the functions are defined, otherwise we do not need memory. So, just because I am anticipating that someday this room may require 1000 things, I am not creating that capacity today. May need, how will I know? We wish that this entire facility will grow in leaps and bounds, and lot of other things are happening, many more things will come, maybe 1000 things capacity can easily be anticipated, but then right now I have not made any provision for it. As and when it comes, we will make sure the capacity is anticipated, but we do not make provision. A nice way of efficiently managing the resources, a nice way of structuring. So, in reality it is true, if this vending machine is successful, we will have 500 snack items because a great place, great area, very well received, but then do we make the machine today to take care of 500? The answer is no. We need to engineer our way. So, therefore, we will not talk so many things right away, but that is how we were doing earlier. Our specification was always beginning with that. We have to decide on many things. That takes time because only 30% of the requirements can be stable. Here you just get on with it, a reasonable number, a good guesstimate, or simply tell that what are all the models available, based on the best model we will create which suits the purse, we can just get on, we can get on building things. So, member functions are there, that is a member function that tells these are the operations. In a sense, an object is something that has data and operations performing on that data limited exactly to that object. Nobody else, no other object is working on the data or the functions. They have to go through this object definition, and these objects belong to a class. A class is defined. So, this is how we have started talking about it. We talk about class definition, information hiding to prevent direct access from outside the class. So, what is the class having? Nobody else needs to know. They only need to know this is the name of the class. This is how you create the objects. Access specifiers, some are public, some are private, some are protected. All 3 varieties are possible: optional, repeatable, not ordered. You can have all the 3, you may have only one, they can be repeated. So, what we need to understand is the class as such, the internals are not known, but the interface is known. Some are public interfaces, certain things are known only to the class, certain things are virtually protected. So, we have spoken about the language, a syntax, a time class, what is an object, set of methods, operations, internal state of the data. Private access specifier facilitates data hiding. Public set and get function allows clients to access data, but not indirectly. Class may store data in one way, however, shows to the client in a different way. It is up to the way we are demonstrating the class. There is no need for the user to know that how many objects can that class instantiate. That is up to us, as many as necessary. If there are only 30 flights that are flying, only that much. 300 flights, we can create that. It shows remarkable scalability. So, essentially we are summarizing what we have discussed. A class interface is necessary. What is the language? We will decide later. Examples have been taken from a language called C++, which is very popular. Most of the syllabi teach that particular language, so you must be familiar with this language. So, all that we want to do is in our language, in the lingua franca of programming and software engineering, we want to talk about class interface, we need to talk about header files, we need to talk about an interface, we need to talk about what defines the service client can use, not how the class will carry out those services. It will only tell these are the services which the class can perform. A classes interface consists of the public member functions. Some functionality is known, some functionality is hidden. This is the summary, and this can be expressed in any object oriented language. Right now we have chosen C++. There is no guarantee or there is no necessity to think that only C++ is there for object oriented analysis and design. It is a good language. It is something which we can talk about. Thank you. We will see again in the next lecture.